That's coming up Wednesday next week is the date I'm setting for that. What's the date on Wednesday next week going to be? Today's the 14th. So that would be the 20th, I think. So February the 20th, you should count on a test when you come in. One of my biggest issues and one of my biggest concerns in grading your homework is your ability to use the FOIL method in multiplying these expressions, primarily binomial expressions, okay? Now, okay, we need to look at the FOIL method and how this works, all right? Now remember, what does this stand for?
First, outer, inner.
Yeah, F is first, outer, inner, and then if I can get this in here, last, right? So on number 28, let's look at this one first. I know your assignment was 40 through 78, but they all work the same. This one's a little bit easier to see how to work it, just because of the nature of the numbers in the expression. 3r plus 4, and then 3r plus 4 again, all right? Now, another way to have written this would have been 3r plus 4. You might see it presented like this in another type of a problem or on a test. 3r plus 4 in parentheses squared. But this is what you should be thinking the way it's actually written in the book. All right? Now, first outers, inners, lefts. Right? Now, you could think in terms of the expanded way that I had asked you guys to think of these problems to do the multiplication. 3r times 3r plus 4, right? This 3r is right there. And then this, of course, is represented there in that parenthesis. My plus here, I'm going to put this sign right here. I'm going to place right there. All right. Now I'm going to put my 4. You know where the 4 came from. The 4 came from right there. Then I'm going to put the 3r plus 4 down here again. All right. Another way of stating this is that everything in the first set of the parentheses times everything in the second. Use your distributive property, work your way across. Or what you could do is this. Save you a little bit of space. This may be the process of the method that works for you. Another way of thinking about doing the same thing, I'm going to write the problem down here again. All right? Now, you know what first, outers, inners, last means, right? First means the two first terms, right? These two right here. The outer terms here, right? The inner terms are right here, and then the two last terms there, all right? So this is just another way of using the distributive process, and it's sort of a shorthand, you know, asking you to keep up with a lot of the things going on in your head, which you can do that. So, but as you can see, this actually does the same thing that I actually drew out with an expanded form here on the board. I'm asking you to take 3r and multiply by both terms. Then once you do that, then multiply the 4 times both terms. You should come out here with 3r times 3r is not 6r, nor is it 9r, nor is it 3r squared, or 6r squared. 9r squared. Now, I just mentioned that because that kind of covers the plethora of type of problems I see when y'all are trying to work some of these out, some of the same types of mistakes that I see being made. Then 3r times 4. What you should get here is 12r, right? And the same thing when I multiply this 4 times that 3r, you're going to get 12r again. All right? My two last terms, 4 times 4, 16. Now, another problem you guys have made consistently on this, on these types of problems is you would stop here. If you did all the math right, you didn't go all the way because you would stop right here. But you can't stop yet because you've got like terms that need to be combined into one term. And so what you have to do is this, 9r squared plus 24r, not 24r squared, you're not multiplying here, you're adding, then plus 16. All right, now, this is where you should stop. Some of you, the mistakes that you made is you got to this point, but then you didn't stop. And you continue adding, trying to force these three terms like these together into one term. And maybe you would add the 9, the 24, and the 16 together, and maybe put an arc to the third next to it or something like that. So these are the once you get here, there are no more like terms, so don't try to drive beyond this point. This is it. Okay? So admittedly, number 28 is a little bit easier than some of the other ones, but still the ideas are the same. All right? They try to confuse you with some complicated expressions. If I move down to number 40, I don't know, let me think about one that I want to do here. Well, let me go to 40, okay? Skipping down to number 40. 2a squared minus b squared, right? And 3a to the second minus 2b to the second. Okay, so we have to use the FOIL method here. And let's use a little bit more of the shorthand version instead of the expanded version, how I've shown you guys to do before. And we're going to multiply the two first terms together to begin with. And when we do that, what do we get? 2 times 3 is 6. Most of you would get that. But the mistake I would see in a problem like this is you did not add your exponents when you multiply the a parts together. You should get a to the fourth, but I would see like a to the second. And you don't want to do that. It's a to the fourth. Okay? Now, from here, we have to move from the two first terms to the two outer terms. 2a squared and a negative 2b squared. Most of you would get this one right. You might miss the sign change, but at least you got the 4. Then you can park a squared and b squared next to each other. Didn't really see a lot of problems on that part. Now we got to go to the two inner terms here. Okay? B squared, negative b squared times a positive 3a squared. Negative 3a squared b squared. You might be tempted to say b squared 3a. Some of y'all would do stuff like that. You would write b squared 3a squared. I would see something like that. That's really not how you want to express the combination of terms under the process of multiplication here. You always want to put the numeric part first and the literal or the letter parts in alphabetical order. And so this is really not what you want to do right here, okay? So not this, but you want to keep it here. Now your last term, your two last terms, right here, negative b squared and a negative 2b squared. Sometimes some of you would mess up on the sign changes here, but you've got a negative times a negative, so that is going to give you a positive. Didn't see a lot of issues with that, but a few. And usually I would see a proper multiplication on the end as well. So usually with the exponent on the variables, when you have more than one variable in an expression like this one, a and b, I would see, for the most part, pretty accurate rendition of the first and last terms. But I saw the problems that I saw. Actually, I got that backwards. It's the first and last terms I saw most of the problems with. It's the middle terms that you guys didn't have as much trouble with, at least at this stage of the game. Now, we have to combine our like terms. 6, a to the fourth. Under the order of operation, we're talking about subtraction here, what I mean. Two negatives, when you're combining them together, you're going to get a bigger negative. You're not multiplying here. You're basically adding two negatives together. So that should be a minus 7 a squared b squared. All right? And then, and again, like with the other ones, do not go beyond this point. All right? With some exceptions, typically when you multiply a binomial expression times a binomial expression, there are exceptions to this, of course, but generally speaking, you're going to get a 3-term answer. Okay? If I jump down to let me think. Okay, let's go down to number 62. I'm going to jump around here a little bit. All right, number 62. 2.5 plus 12 looks like p squared q squared r to the third. P squared q squared r to the third. And this is the problem then parentheses squared, right? So expand it out. What you're going to do, 2.5, let me fix that. All right. All right, so here we go. This is the problem number 62. All right. Problem 62, write it out twice, make sure you don't miss anything. And with problems like this, it'd be a good idea to have a calculator to make sure you get the decimal point in the right place. But it's see some issues with that. What is 2.5 times 2.5? Somebody with a calculator. Somebody pull that up. All right, 2.5 times 2.5. 6.25. 25 times 25 is 625. 2.25 times itself, 6.25. That would be my two first terms. Now, what about 2.5 times 12 p squared q squared r to the third? What's that going to give us? All right, so the answer here, I'm taking y'all's word for that. 30 p squared q squared r to the third. Now, since I'm playing with the same situation here, when I'm multiplying my two inner terms together, then I can just repeat this, right? Well, you did it right the first time, you did it right the second time. If you messed up the first time, you messed up the second time. All right, now the last term, 12 times 12, you should think 144. Now, what do I do with the variables and their exponents? Q, or p to the fourth, q to the fourth, r to the sixth of the ninth. 6, right. So we're going to go P4, Q4, and R6. All right? So it's the same process, so don't let this, just because you have a decimal number in here and you have the second term, 12p squared, q squared, r to the third, 3 variables in there, raised to different exponents. Don't let that intimidate you. It's the same process. So your final answer, 6.25, your two outer and inner terms, the two middle terms here in the process of multiplying here, they're like terms, so they get added together. That's my ugly Q. R to the third. So don't mess with the exponents. Don't mess with the exponents when you mess with this, okay? We just tag the last term down. P4, Q4, R6. Okay? That would be your answer. So don't go beyond that point. Let me do one more, then I think I'm going to stop. I think I'll jump down to what was one of the problems? All right, I'm going to do one more. I'm going to do problem number 61. Okay? Okay, this is the problem. It actually reads in your book, a to the m to the a plus 2 minus n to the b n, and then in parentheses squared. I went ahead and just wrote it out twice because that's what you've got to do anyway. And now what I'm going to do is multiply my two first terms together. M to the a plus 2 times m to the a plus 2. Like bases, what do you do with the exponents? What do you do with the exponents when the bases are the same? You add them. So we have to say a plus 2 plus a plus 2. And I'm going to write it out like that for right now, okay? We got to combine those terms in the exponent in just a minute, but for the time being, I'm going to leave it there. Now my two outer terms, okay? What am I going to get here? M to the a plus 2 times m to the b times n. The m's, I have a like base here, so what I've got here is this. By the way, this is a negative, so I'm going to have to subtract. My base is m, a plus 2 plus b. I'm going to put a plus b plus 2, okay? Let's keep the letters first and numbers last. I have to add my exponents. So you wouldn't multiply a plus 2 times b. You have to add b to it. And since they're no like terms, that's not going to be able to change. So that happens with my outer terms. What about my inner terms? I have a negative here, okay? M to the b n times m to the a plus 2. Again, same thing with the base m. And I forgot to do something here first of all. Hang on. Approximately my two inner terms, I'm going to get the same thing here again. M to the a plus b plus 2 times n. Okay? Now my two last terms, so that's my two inner terms. My two last terms here. M to the b n times the negative m to the b n. Two negatives, you're going to get a positive first result on that. n to the b times n to the b is n to the b plus b. And then you've got n times n, which is going to be what? I hope you tell me n squared. Okay? All right. Now that's basically, well, let's rewrite this now with simplified exponents. What about this? I'm going to say, what's a plus a? 2a, and then 2 plus 2 is 4, so I can write my first term and then to the 2a plus 4. And then my two middle terms are identical. Well, they're like terms, and they're going to combine into a bigger term. So when I add these together, I have two of them, right? So 2m a plus b plus 2n. I've got two of them. They're like terms. And then at the end, n to the b plus b is, what's b plus b? 2b, I hope, not b squared, but it's going to be 2b. N to the 2b n squared. Now, this is a weird answer. I know, because it was a weird problem, but it follows the same process. Okay? I want to stop here with this, and I'm going to post this so you guys can listen to this again. I was able to keep this about 16 and a half minutes. Good luck.